Hello everyone, I'm MM'25 from Peking University. Today I'd like to present our written work titled Advancing 3D Scene Understanding with MV-ScanQA, Multi-View Reasoning Evaluation, and a TripAlign Pretrain dataset. This research addresses a fundamental challenge on how visual language models understand three-dimensional environments. Before diving into the details, let me first give you an overview of our work. Through our analysis, we discovered a critical limitation in current 3D visual language learning methods. Surprisingly, for 93% of samples of existing 3D visual language datasets, single 2D view suffices to solve the task. This means that models trained on these datasets fundamentally fail to capture true 3D spatial relationships, especially for long-range objects that require understanding from multiple viewpoints. To address this significant gap, our work makes three key contributions. First, the MV-ScanQA, a challenge multi-view 3D question answering benchmark where 68% of the questions require multi-view reasoning. That's more than 10 times the proportion found in previous datasets. Second, we present the TripAlign, a large-scale dense multi-object alignment dataset containing over 1 million carefully curated triplets. Finally, the LEGO, a novel 2D 3D visual language baseline model that effectively transfers knowledge from the pre-trained 2D visual language models to 3D domain using our TripAlign dataset. Now you might wonder, why is this problem so important? It is a failure that we call single-view bottleneck of current 3D visual language benchmarks or datasets, that 93% of the samples can be solved from just one single viewpoint. When a model can answer questions about a 3D scene from just one viewpoint, it's essentially solving a 2D problem, not truly understanding the 3D structure. Models trained on these datasets don't need to develop genuine 3D scene understanding capabilities. Further, existing datasets provide only sparse, single-object annotations. They miss the rich multi-object alignment signals that are absolutely critical for robust scene understanding. Let's now delve into our first contribution, the MV-ScanQA dataset. We try to craft the truly multi-view questions with our carefully designed steps. We begin by synthesizing complex compositional questions from existing single-view questions using LLMs. We specifically select questions that involve overlapping object anchors, meaning that they involve relevant but not mutually inclusive objects to each other question. In that way, we enforce that the questions require complementary information from multiple viewpoints. The result is remarkable. In MV-ScanQA, 68% of questions require at least two views to answer correctly, and even 13% need three or more views. Our second contribution, the TripAlign dataset. It addresses the sparse annotation problem through dense multi-object alignment. Our generation pipeline employs two complementary strategies. First, we generate high-quality captions from egocentric views by 2D image captioners, which are then filtered to ensure quality and relevance. Second, we extend existing 3D visual language datasets by adding instruction-relevant 2D views. This creates a rich set of connections between different modalities. The outcome is impressive. We generate over 1 million triplets that inform of 2D view, object groups, text, triplets, providing rich understanding of 3D scenes. Let me briefly introduce LEGO, our proposed model that leverages these datasets. The key insight is that LEGO builds upon pre-trained 2D large visual language models rather than text-only LLMs. This allows us to transfer rich visual understanding from 2D to 3D domain. Through our proposed view-dependent multi-object alignment mechanism and training with TripAlign's 2D 3D language triplets, LEGO could bridge the gap between 2D visual language knowledge and 3D understanding. For evaluation, we test LEGO on multiple benchmarks, our MV-ScanQA for multi-view reasoning, ScanQA for general 3D question answering, and ScanRefer and NR3D for dense captioning. We use the standard metrics for question answering and captioning quality. The experimental results shown here validate the effectiveness of our approach across all benchmarks. On MV-ScanQA, LEGO outperforms existing methods by significant margins, particularly excelling on questions requiring 4 or more views with a 7% improvement. On general question answering and dense captioning tasks, LEGO also set new records on evaluated metrics. These consistent improvements validate both our dense multi-object training approach and the importance of proper multi-view evaluation. In brief conclusion, our work addresses fundamental limitations in current three-dimensional language learning through three interconnected contributions. For more detailed information about our methodology, additional experimental results, and access to our datasets and code, please scan the QR code to visit our project page. Thank you very much for your attention.